Hello my dear students, I am B S Pandey, your physics lecturer. Today my dear students, we are in lecture number 76 of standard 12th. Student, in last lecture we have studied the AC supplied through inductor. Today we will study about the capacitive circuit. But before that, my dear students, we will draw the sinusoidal graph of inductive circuit that we have left in last class, last lecture. I have given you homework. I hope the number of students you have made and reach to the correct answer. But I will start today's lecture from that topic. It is lecture number 76. Of chapter 7 in CRT. We are in AC, alternating current. Those students have not seen previous lecture, kindly go through that. Then only you will be able to understand the sinusoidal graph I am going to discuss right now. Okay, my dear student? For inductive circuit, we have made, if it is inductor connected under AC of E naught sin omega t, okay, so ET was E naught sin omega t and IT we got I naught sin omega t minus pi by 2, or you can write minus I naught cos omega t directly. Okay, power we got P t instantaneous value as the product of this two minus E naught I naught divided by 2, you can write sine 2 omega t. Could you write? Yes. But remember, the phase of this ET, it is omega t, and for current it is omega t, but the phase of this one, it is 2 omega t. Remember, it is 2 omega t, and it will change the frequency of instantaneous power. Remember how? Try to recall standard 11. You can find out the frequency of this one. First try to find out the time period. So the 2 omega t equals 2 omega dash t. I hope you remember how to find. It is 2 omega, it is 2 pi by t. T will be cancelled out. It equals to 2 pi by t dash. So the t dash will be t by 2. You can see the time period become half, so the frequency will be doubled. F dash will be 2f. Frequency will be double. This will help you to draw the sinusoidal graph. I am going to draw. Okay. Now, we know that the amplitude of current is little less than the voltage. This is for the current and this is for the voltage. Right now I am drawing, it is for the voltage. But what about the power, my dear students? The power amplitude will be greater then all these two current and voltage. So this red one is the graph peak value of power. This is 0. First we are going to draw the graph sinusoidal of voltage. Okay. So this is the graph of sine. Start from here, and this is our I naught, this is our E naught, and this is our T naught. Okay. So the voltage graph looks like this one. You can write here minus I naught minus E naught minus P naught. Now the next graph is for the current. So the current graph, you can see here, my dear student, this equation, current graph starting from negative with the same phase but of cosine. Not exactly the same phase, it is the omega t minus pi by 2, but the frequency is the same. Okay. So the graph will start from the cosine start from maximum, but the negative start from maximum negative. So it will start from here for the current, and this is the time period. This is also very important to draw the time period, otherwise the graph will not looks like very nice. Looks very nice. Okay. Here the current is going from maximum negative and it reach to the 0 where the voltage reach to the maximum. Look at here, this one, it reach to the 0 and it reach to the maximum. It comes down here, it goes to the again maximum. The parameter you will draw clearly, the graph will be very crystal clear, and really you will enjoy, my dear students, plotting this graph because these are not very tough. Now for the power, the frequency of power should be high. It means if current on the voltage, if this voltage making this one cycle in this one, so the power will have the one cycle in half cycle of the current. Am I right? So this is the graph of power. And remember the power, it will be goes from minus, no, I think minus half of E naught I naught, the product of E naught I naught half. So it should be start from negative 1 from here, and we have to complete the graph in this way. Okay, then I think it is not completed. Let me draw a little more clear. This is the only half cycle it was. That's why I told you, you can make more clear by drawing these values. Okay. From here we will start and we'll go to the 0. Look at here carefully. We'll go to the 0 will be here because it is the graph of sine, I have started from here. That's what the wrong. It is the graph of sine. So it will start from here, and after one complete cycle we have to reach, remember, we have to reach to the this point, to this point. I think now we are successfully reaching to the correct value. Yes, so that's one. Now this one. So this is the graph of power. I hope this is not very difficult, because you can move back in video to see the current individually, then voltage, and then power graph. But this is very important, how to draw the three graphs. This is very important, that's why I've drawn. Now I don't think that I have to draw the sinusoidal graph of all the quantities, because you know very well how to draw it. Okay, now let me draw it. One more thing we have left for inductive circuit, it was the graph I told you. My dear students, could you draw the graph of inductive reactance with angular frequency and inductance? Inductive reactance with angular frequency, and the second graph, inductive reactance with the inductance. Could you plot? Yes, you can. Try to plot. We know that XL is L times omega. Am I right? It is L times omega. And for L constant, okay, this XL will be directly proportional to omega, and here for omega constant, XL will be directly proportional to L. As you will increase the inductance, XL will increase, and for both the graph will be a straight line like this one. Okay, and the slope will give you something you can understand very well. Now one more question. This question I have taken from NCERT. This question was asked in board exam also. Okay, you can find this is example 7.5 I think of NCERT of this chapter. What is the question? There is an inductor and an electric bulb. When AC source applied, a switch is provided and the AC source. Okay. Now the question, switch is closed, it glows, but what will happen if we will introduce a iron rod, ferromagnetic rod inside the coil of inductor? What will happen to the glow of bulb? And the options are given. It will decrease, it will increase, it remain unchanged, etc., etc. Okay, try to think what should be the answer. I hope you understand the question. Let me tell you again the question. An inductor connected with a bulb in series, which is supplied by AC source. When switch is closed, bulb glows. Now if you insert a ferromagnetic rod inside the inductor coil, what will happen to the glow of bulb? And the answer is, my dear students, we know that the inductive reactance, we used to write XL, it is L omega. Okay, XL, L omega. If it will increase, the voltage across the inductor will increase, no doubt. Voltage will increase. And if the total voltage suppose 100, it is taking 50, but due to increase in resistance, the voltage increase, it becomes 75, then how much it will get? Only 25. And if it is getting less voltage, what will happen? Its glow will down. Okay, reduce, decrease. Now look at here. As you will insert the ferromagnetic substance, that is the iron rod, inside the coil of inductor, its inductance will increase. Try to recall from electromagnetic induction chapter. Inductance will increase, L will increase, and due to increase in L, XL will increase, and voltage will also increase. We know that the voltage will also increase, and due to increase in the voltage across the inductor, across the bulb, the voltage will drop down. So the brightness of bulb will decrease. This is the answer. The brightness of bulb will decrease. Okay. Now, next circuit will start. It is capacitive circuit. In this circuit, I know that you can draw the Phasor diagram by yourself. You can draw the sinusoidal graph by yourself. Even you can calculate the average power as well. Okay. Here, capacitor under AC supply. Capacitor under AC supply. That is pure capacitive circuit. Few topics of this capacitive circuit we will discuss in next lecture, my dear students. Okay, because I don't want to teach you in very fast way. Okay, this is the capacitor connected with AC source. E naught sine omega t. Capacitance is C. The instantaneous current, it is IT. Alright. Now, what will happen? According to Kirchhoff's voltage law, we can write the E naught sine omega t minus how much voltage drop across the capacitor, my dear student? Q by C. Alright. Here the voltage drop, how much? Q by C. So, it is Q by C equals to 0. Or we can write E naught sine omega t is equals to Q by C. Or E naught C sine omega t equals to Q. But we have to reach to the current. And we have reached to charge. Could you find the current from here? Yes. Differentiating this equation with respect to time. dq by dt. What will have? d E naught c sine omega t divided by dt. This will be the I. Since the charge is not constant, it is the function of time. So the current will also change because charge is variable. If charge will be constant, it's quite clear this will be the entire 0. But it is changing. So IT we can write E naught is constant, C is constant, d sine omega t over dt. It is E naught C and definition of sin omega t will be omega times cos omega t. Am I right? Yes. So it we can write it is E naught c omega cos omega t. Again, my dear student, you can see if this is a number and this is a current, of course this should be the current, and a current always gives by, if it is the voltage, alright, if it is voltage, then by dividing some quantity we can have the current. So we can write this one as E naught divided by 1 by c omega. Could we write 1 by c omega? There is no difference. Cos omega t. This is it. Yes. Now, if this amount is resistance, if this factor, if this amount is resistance, then of course it becomes current. And yes, it is resistance, but this is known as the capacitive reactance. It is called capacitive reactance. And what is that capacitive reactance? The resistance offered by capacitor to the alternating current is called the capacitive reactance. Okay, and its value is 1 by c omega, where omega is 2 pi f. Understand? Yes. Now this value it can be written as, if it is resistance, then it will be I naught cos omega t. Remember, this capacitive reactance will also have the same unit as the resistance. It is ohm. To compare the phase of current and voltage, we need to convert in sine form, and we can convert in sine form. This one, what we can write, my dear students? We can write I naught sine omega t plus pi by 2. I hope you understand. Yes. So we have voltage, it is E naught sine omega t. We have calculated the current, it is I naught sine omega t plus pi by 2. Now you can compare the phase. The phase of voltage is omega t, whereas phase of current is omega t plus pi by 2. Which one is leading in the circuit? Yes, current is leading and voltage now lagging. By what angle? Pi by 2. It might be in examination you will be asked, prove that current lead by pi by 2 in capacitive circuit. So using this particular derivation you can prove in examination, in your board examination. Okay. Alright. So my dear students, we can write here now for capacitive circuit, the important things, my dear students, the capacitive reactance, what we got? 1 by c omega. Okay, 1 by c omega. Few questions you can form from there also. Here, Et equals to E naught sine omega t, It equals to I naught sine omega t plus pi by 2. So phase difference you can write plus pi by 2. Okay, for which circuit? For capacitive circuit. Now we are going to draw here the phasor diagram, but before that we will calculate instantaneous and average power. So instantaneous power, that is the PT into IT. and it is E naught sine omega t into I naught sine omega t plus pi by 2, or E naught I naught, this is sine omega t into cos omega t, am I right? Multiplying, dividing by 2, you will have sine 2 omega t. This is the instantaneous power. Now average power. You can see again the instantaneous power having the same magnitude. It is I naught E naught I naught by 2 as inductive circuit, and frequency again it is twice the frequency of AC current and voltage, as it was same in inductive circuit. Now the average power. So the average power, my dear students, it is Pt dt. Again and again I used to write this formula. You should remember E naught I naught by 2 sine 2 omega t dt by t for full cycle. Directly we can write. Again you try to recall, in inductive circuit we were having this value as 0, so this will be also 0 again here. Again the power is 0 and there is a current in the circuit. For capacitive circuit also the current we will get, it is termed as the waterless current, because there is no voltage, even current flowing through the circuit. That's why it is called waterless current. Okay, my dear students, that's why it is called waterless current. Could you make the phasor diagram now? Because I'm not going to make the sinusoidal diagram. You have to make by yourself. I have taught you 2 times. The same thing if you need to learn here again and again, then your learning will be not quite good. Okay. So the phasor diagram, even you can draw the phasor diagram also by yourself. Okay. Which one is leading over here? Current or voltage? Yes, it is current leading in capacitive circuit. So the phasor diagram, this is the voltage E naught, the peak value Et, how much it rotated, omega t. Now we have to rotate which quantity? Current. Et, we know that it was E naught sine omega t, but current we know that it is I naught sine omega t plus pi by 2. Its phase will be pi by 2 more than the voltage. It means omega 2 it will rotate, but it will goes more by pi by 2. If this is pi by 2, this entire value will be how much? It is omega t plus pi by 2. I hope you understand. And what is this? I naught. And this will give you IT. Okay, so this is the phasor of pure capacitive circuit. Okay, now one question, the very simple question, my dear students. Could you plot the graph of capacitive reactance with the angular frequency or frequency, linear frequency. It has been asked in examination, or if you will be asked to draw with the capacitors at constant angular frequency. Could you draw? Yes, we can draw this graph. How many students? Xc we know that 1 by c omega. Am I right? It is 1 by c omega. If c is constant, then Xc will be inversely proportional to omega at c constant. And if Xc is inversely proportional to omega, then you know that the graph will be like this way. Now, second one, since omega is 2 pi f, so Xc will be inversely proportional to again 2f. So the graph will be same like this way. Now here, for this one, we know that here the Xc 1 by c omega. If omega is constant, again c is inversely proportional to x. At omega is constant, Xc again inversely proportional to c. All the graphs are similar. So this is the graph of different quantities. Okay, my dear students. Now there is again an experiment. Okay, there's again an experiment in NCERT that we will discuss in next lecture, and we will solve numerical question, how to handle the numerical question on the basis of this 3 circuits: resistive, capacitive and inductive circuit. Experiment number 7.3, it is mentioned in NCERT, my dear student. It is mentioned in NCERT, which will give you the concept of this capacitive circuit. Okay, my dear students. So try to go to the NCERT and see that experiment. Alright, so this is all about today's lecture, my dear students. We will continue the lectures of numerical problem solving. That will be the very important, the next lecture. Okay, my dear students, thank you very much.